Welcome back to 6-Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today for our video on factoring complex trinomials using the box method, the extended version. Make sure you're subscribed to 6-Minute Math for more tips, tricks, hints, and hacks to make your math journey easier. We will not have a time limit today, as this is an extended version, and I want to give ample time to make sure all of you understand this complicated process. Let's get into our key points. The first thing we're going to do when we are factoring complex trinomials is that we are going to create a factor u of that a times c value. If you are unfamiliar with what a factor u is, be sure to check out our video called What is a Factor, which will help explain that process. Then we're going to find two numbers that add or subtract to that middle b value. We're going to create a polynomial using 4 terms by splitting this b value into two factors that we found in our first step. And then we're going to place these terms into a 2x2 box, left to right, top to bottom. We are going to factor each row and column, and what we get from when we factor these rows and columns is the terms on the outside will create our binomial factors. This is best demonstrated by an example, so let's check one out together. We are going to factor 2x squared plus 9x plus 10. So our first step is to analyze. We have our a, b, and c value, and we're going to create a factor u of that a times c value. 2 times 10 is 20, so we have our factor u for 20. Our next step is we're going to find two numbers that add or subtract to that b value. How do we know whether we are adding or subtracting? We are going to look at the operation next to our c value. This tells me that we are adding our c value, so I'm going to look for two numbers that add to that b value. That, of course, is going to be 4 and 5. So I'm going to take my b value and I'm going to split it into two terms. We're going to split 9x here into 4x and 5x, and our a and c values remain the same. We have our box, and we're going to write our terms in left to right, top to bottom. So we fill in our 2x2 box. 2x squared is going to go in the top left. 4x is going to go beside it. 5x is going to go in the lower left. And positive 10 is going to take that last spot. Now that I have my terms inside my box, I am going to factor each row and column. So I factor 2x squared plus 4x. The greatest common factor in those two terms is 2x. If I factor 5x plus 10, my greatest common factor between those two terms is positive 5. How about I do the columns now? 2x squared plus 5x. My greatest common factor is a single x. And then if I factor 4x plus 10, my greatest common factor is a positive 2. On to our last step here, where we are going to take the outside terms and create our binomial factors. So our top two terms are going to be x plus 2, and our side two terms are going to be 2x plus 5, giving us our final two factors from 2x squared plus 9x plus 10. So let's check out some examples together here. We're going to factor 6x squared plus 11x plus 3. 6 times 3 is 18, and I have my factor u for 18. I am looking for two numbers that add per my C operation to that middle B value. Well, two numbers that add to 11. Let's just do some quick sums here. We have 19, 11, and 9. So that tells me I'm going to be using 2 and 9. So I'm going to take my 11x and I'm going to split that into 2x and 9x. And I'm going to drop my A and C values as well. I have my polynomial here, and now I can put my terms in a box. So we're going to go left to right, top to bottom. We have 6x squared plus 2x plus 9x plus 3. I'm going to factor my rows and columns. 6x squared and 2x. I can take out a 2x. 9x plus 3. I can take out a positive 3. Onto my columns. 6x squared and 9x. I can take out a 3x. And then 2x plus 3. There's no greatest common factor, but I have to take something out, so I'm going to take out a positive 1. These are now going to be my binomial factors. We have 3x plus 1 and 2x plus 3. So we have our 3x plus 1, 2x plus 3. Let's check out another example here. We have 8y squared minus 2y minus 3. 8 times 3 is 24, and I have my factor u. I'm looking for two numbers that subtract to this middle b value of 2. So let's do some differences here. We have 23, 10, 5, and 2. I'm looking for it to be a 2. So that tells me I'm going to split that middle b value into 4 and 6. So we have 4y and 6y. And then we need to decide which one's positive, which one's negative. I have a negative b value, which tells me my higher term is going to be the negative one. Let's drop our a and our c. And now we have our 4 terms to put into our box. Left to right, top to bottom, we have 8y squared plus 4y minus 6y minus 3. Let's factor our rows first. 8y squared and 4y. That factors to 4y. Negative 6y minus 3. I can take out a negative 3. Why am I including that negative there? If the edge operation or term is a negative, we're going to take out that into our binomial. Let's factor our columns. 8y squared minus 6y. I can take out a 2y. And then 4y minus 3 doesn't have a greatest common factor, but I have to take something out, so positive 1. This gives me my two binomials of 2y plus 1 and 4y minus 3. Let's check out another example here. We're going to factor 4x squared minus 10x plus 6. 4 times 6 is 24, and I have my factor u. Now I'm looking for two numbers that are going to add to that middle b value of 10. So let's do some quick sums. We have 25, 14, 11, and 10. We're looking for it to be 10. So I can split that middle b value up using my 4 and my 6. Both of them are going to be negative in this case because I have a negative 10x. Let's drop that a and c values. We have 4x squared and positive 6. And let's put some numbers into our box. 4x squared minus 4x and negative 6x plus 6. Well, let's factor this row. 4x squared minus 4x. Well, I can take out a 4x from that. Negative 6x plus 6. Well, I can take out a negative 6. Please remember that if our edge term is a negative, that negative is going to come out into our binomial. Let's factor the columns now. 4x squared and negative 6x. There's actually nothing I can take out of that except for a positive x. And then negative 4x plus 6. Again, I can't take any greatest common factor out of that, but I have to take out something. So I'm going to take out a 1. And because that edge term is a negative, it's actually going to be a negative 1, giving us our final binomials of x minus 1 times 4x minus 6. What about if I were to factor 9x squared minus 12x minus 5? 9 times 5 is 45. And I have my factor u. I'm looking for two numbers that are going to subtract to 12. So let's do some differences here. We have 44, 12, and 4. This tells us we're using 3 and 15. Let's split that 12 up into 15x and 3x. Which one's positive? Which one's negative? Well, I have a negative here, which tells me my higher value needs to be negative, and my other one is going to be positive. Let's drop that a and c values. And now we can factor. 9x squared minus 15x plus 3 minus 5 goes into our box, and we factor the rows and columns. 9x squared minus 15x. Well, I can take a 3x out of that. Positive 3x minus 5 doesn't have a greatest common factor, so I'm going to take out a positive 1. Onto the columns, 9x squared plus 3x. Well, I can take out a positive 3x. And negative 15x minus 5. My greatest common factor in that is going to be negative 5 because that edge value is a negative. This gives me my final binomial terms of 3x minus 5 times 3x plus 1. What if I were to factor 6x squared minus 23x plus 7? 6 times 7 is 42, and I have my factor u. And I'm looking for two numbers that add to that middle b value. Let's sum these up. We have 43, 23, 17, and 13. I'm looking for two numbers that add to 23. So this is going to be 2 and 21. So let's split that up into 21x and 2x. Both of them are going to be negative to match up that middle b value. And then I can drop my A and my C. Let's put some numbers into our box. We have 6x squared minus 21x minus 2x plus 7. 6x squared and negative 21x. There's only one factor I can take out of that, which is x. Negative 2x plus 7. Again, there's only one factor I can take out of a 1. And because this edge value is negative, it's going to be a negative 1. Column-wise, 6x squared minus 2x. Well, what can I take out of that? I can take out a 2x. And then negative 21x plus 7. I actually can take out a negative 7 for that one. This process gives me my final binomials of 2x minus 7 and x minus 1. We have a couple more examples here. We're going to factor 9y squared plus 13y minus 10. 9 times 10 is 90. And I'm looking for two numbers that subtract to that middle b value. So we have our differences here. 43, 27, 13, 9, and 1. We're looking for it to be 13, so I'm going to be using 5 and 18 here. Let's split that up into 18y and 5y. And I'm going to have my 18 be positive, so that middle b value, after combining those two terms, would be a positive. We have 9y squared and negative 10 as my a and c values, which I need to put into my box. 9y squared plus 18y negative 5y minus 10. 9y squared and 18y factors very nicely to 9y. And negative 5y minus 10 also factors nicely. I'm going to give this a negative 5. 9y squared and negative 5y. There's only one factor I can take out of that, which is a y. And 18y minus 10. I only have one factor I can take out of that, which is positive 2. This gives me my binomial factors of y plus 2 times 9y minus 5. On to our last example here. We're going to factor 10x squared plus 19x plus 6. 10 times 6 is 60, and I have my factor u, which I'm going to use to find two numbers that add to that middle b value of 19. We have 61, 32, 23, 19, 17, and 16. I'm looking for it to be 19, so I'm going to use my 4 and my 15. This 19x is going to split up into 15x and 4x, both of those positive. And then our a and our c values will drop. I'm going to use all those terms in my box. We have 10x squared plus 15x plus 4x plus 6. 10x squared plus 15x. I can take out a 5x in that case. And 4x plus 6. I can take out a positive 2. 10x squared plus 4x. I can take out a 2x. And 15x plus 6. I'm going to take out a positive 3. This gives me my final binomial factoring of 2x plus 3 times 5x plus 2. Those are all the examples we have today for factoring complex trinomials using the box method. Make sure you're following us on Instagram and TikTok at 6Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing. And until next time, keep solving and evolving.